Hi, this is the third video about developing language test items. In this lesson, I will explain item analysis techniques for norm reference tests, which are more common for English teachers. Item analysis techniques include item facility and item discrimination analysis. Certain procedures will be explained for analyzing and selecting items in order to create an improved version of a test from an original version. As usual, the lesson will end with some takeaway questions. Item facility, also called item difficulty, item easiness, or simply IF, is a statistic used to examine the percentage of students who correctly answer a given item. To calculate IF, add up the number of students who correctly answered a particular item and divide that sum by the total number of students who took the test. You can see the equation on the slide. The result of this formula is an item facility value that can range from 0 to 1. By moving the decimal point 2 places to the right, teachers can interpret this value as the percentage of correct answers for a given item. For example, the correct interpretation for an IF index of 0.27 would be that 27% of the students correctly answered the item. In most cases, an item with an IF of 0.27 would be a very difficult question because considerably more students missed it than answered it correctly. In contrast, an IF of 0.96 would indicate that 96% of the students answered correctly. A very easy item because almost everyone responded correctly. Such seemingly simple information can be very useful. For example, consider the item response pattern shown in Table 4.1. As with all testing statistics, the first thing that teachers must do is to arrange the data so that they can easily be examined and manipulated. Notice in the table that the students' names have been listed in the left-hand column and the item numbers for the first 10 items and the total scores are labeled across the top. The actual responses are recorded with a 1 for each correct answer and 0 for a wrong answer. Notice that Shannon answered the first item correctly. Indeed, so did everyone else except poor Archie. This item must have been very easy. Note though that item 1 is not the easiest item. Another item was answered correctly by every student. Which one? Item 5, right? And which item was the most difficult in this data? Item 10 was clearly the most difficult because every student missed it, as indicated by the 0 straight down that column.
Hello, this is part 2 of calculating item facility and item discrimination. Right now we're going to calculate item facility. Notice that I'm using Word, but you could use Excel or any other program to calculate this, but I chose one in which we can work without using technology, one that we could use in the classroom using simple pen and paper. I just quoted this from Brown. It says, if simply reflects the number of students answering the item correctly. And in this case, we are going to analyze item number 6 only from the exams I previously showed you. And in this case, we have to take all the students into account. We are not going to divide the group into thirds or any other number. We are just going to take all of them into account. Here you have the formula we're going to be using. Item facility is going to be equal to the number of students answering the item correctly divided by the total number of students responding to that item. So in this case, item 6, we have that the number of students who answered the item correctly is 7, and the total number of students, as I said before, is going to be 14. So if we divide 7 by 14, we are going to see that it's 0.5. 0.5 is going to be our if or item facility number. This is kind of a line that is going to show us more or less if the item is easy, about right, or difficult. Of course, this is very subjective and you would decide that depending on the type of exam or item you want to have. Maybe you want to have an item that is very easy just to relax your students or so. So this one is 0.5. So it goes right here. It is just about right. Okay? And then it will be my decision to continue using it, modify it, or throw it away, as it says here. There is no absolute if value that must be met to determine if an item should be included in the test as is, modified, or thrown out. But appropriate test items will generally have ifs that range between 0.15 and 0.85. But again, it is your decision to keep, modify, or throw out an item.
Item discrimination, ID, is a statistic that indicates the degree to which an item separates the students who performed well from those who did poorly on the test as a whole. These two groups are sometimes referred to as the high and low scorers, or upper and lower proficiency students. The reason for identifying these two groups is that ID allows teachers to contrast the performances of the upper students on the test with the performances of the lower students. The process begins by determining which students had scores in the top group on the whole test and which had scores in the bottom group. To do this, you must first line up the students' names, their individual item responses, and total scores in descending order based on the total scores. Notice that the order of the listings in Table 4.1 is from high to low based on total scores. Such a high to low arrangement allows for quickly determining which students fall into the high and low groups. Once the data are sorted into groups of students, calculation of the discrimination indexes is easy. To do this, calculate the item facility the same IF discussed before for the upper and lower groups separately for each item. Finally, to calculate the ID index, the IF for the lower group is subtracted from the IF for the upper group on each item, as in the equation on the screen. For example, in Table 4.1, the IF for the upper group on item 4 is 1, because everyone in that group answered it correctly. The IF for the lower group on that item is 0, because everyone in the lower group answered it incorrectly. To calculate the item discrimination index for this item, subtract the IF for the lower group from the IF for the upper group. This will give you an index of the contrasting performance of those students who scored high on the whole test with those who scored low. In this case, the item discrimination turns out to be 1. This is very high because it indicates the maximum contrast between the upper and lower groups of students. That is, all the high students answered correctly and all the students in the lower group answered incorrectly. Consider several other items in Table 4.1. In Item 6, the students in the upper group have an IF of 0.80 and those in the lower group have an IF of 0.20. So, the item discrimination index for Item 6 is 0.60. This ID index indicates that the item is discriminating fairly well between the high students and low students on the whole test. on the other hand, an item like number 9, for which the upper group had an IF of 0.20 and the lower group an IF of 0.60 would have an ID of minus 0.40. This ID index indicates that the item is somehow testing something quite different from the rest of the test, because those who scored low on the whole test managed to correctly answer this item better than those who score high on the total test. Since the multiple observations of the whole test are logically a better estimate than any single item, good reasons exist for doubting the items that have low or negative ID indexes. Let's move on.
Hello again. We are going to continue with item discrimination. According to Brown, it is the extent to which an item differentiates between high and low ability test takers. An item on which high ability students who did well in the test and low ability students who didn't score equally well would have poor ID because it did not discriminate between the two groups. Conversely, an item that garners correct responses from most of the high ability group and incorrect responses from most of the low ability group has good discrimination power. Brown, 2004. In this case, we are going to analyze item number 6 only. For ID, we need to take the high and low ability test takers only into account. This is the formula we are going to be using. ID equals the number of correct responses from the high group minus the number of correct responses from the low group divided by half times the total number of the two comparison groups. If you want to, you can substitute this fraction we have here by 0.5. That makes your understanding of the formula easier. These are the results of item number 6. The number of correct responses from the high group is 5. The number of correct responses from the low group is 1. And the total number of students we are analyzing for this item is 10. 5 of the high group and 5 of the low group. Now, let's substitute the numbers. The ID in this case would equal 5 minus 1 divided by half times 10. That means that the ID is 5 minus 1 equals 4, and half times 10 equals 5. That means that our ID is 4 divided by 5, which is 0.8. Now, this line is going to show us what is acceptable in this case. If your item approaches 0, that means that it does not discriminate very well. If it approaches 1, that means that it discriminates better. Ours is going to be right here in 0.8. And quoting Brown again, as with if or item facility, no absolute rule governs the establishment of acceptable and unacceptable ID indices. That means that it is up to you to decide if the item should be included again, if it should be discarded, or if it should be modified.
Let's move on to the final part, takeaway questions. You should now be able to answer. 1. What is item facility? How to calculate? What is it used for? 2. What is item discrimination? How to calculate? And what is it used for? You can also find more practice exercise in the quiz to fully understand how to use such statistics.